On this channel I have documented the development of my minimalistic 8-bit computer I call the Minimal. The Minimal packs in just a handful of TTL chips, the processing power of a Commodore 64, half a megabyte SSD storage, a tiny operating system, a UART interface, a native assembler, a text editor, a Python-like high-level programming language, and games like Tetris. I think it's fair to say that in terms of where you get the most bang for the chips, the Minimal is quite unique. Back in 2019 I built the first prototype on Breadboards. Fast forward 2 years of iterations, the Minimal has evolved into a mature PCB design and is built by a growing number of fellow minimalists around the world. Getting all that feedback from you guys still just feels amazing to me. Today I want to complete the circle and challenge myself with building a Redux breadboard version again. I have totally reworked the design for utmost build simplicity while keeping everything 100% software compatible to the latest Minimal. Of course the base architecture is still there, but I made a big change by allowing for 24 controlled signals rather than aiming for 16. Hence the CPU now needs 3 chunky control flashes, but this eliminates a great deal of complicated logic. Furthermore, I have achieved significant simplifications in the UART section. I'm finally convinced that it can't be built any simpler. I'll put a link to my Redux schematics down in the description. If you are looking for more info on the general principle of the Minimal, I recommend taking a look at the reference manual or watch some of my earlier videos. All in all, the design now is so clean it almost hurts. IC count is down to 39 compared to 47 of the previous revision. And on top of that, the ICs are now connected in a much simpler way. I figured I'd use 8 breadboards in total and build everything in a nice and modular way. I bought good quality boards from a local electronics shop. The contact resistance between 2 points is consistently less than 1 ohm. My older boards showed readings between 10 and 100 ohms, which is just asking for trouble. Here is my layout plan. We'll have to build a UART module, the memory and a 16-bit memory address register, a 16-bit program counter, 2 8-bit registers with adder, and the control logic with a step counter, instruction register, flag register, and the 3 control flashes holding the microcode. I've made myself a nice and stable support frame to hold the breadboards in place. We'll need around 240 jumper wires plus some longer connections and lots of smaller bits and pieces of wire. And here I've put all the ICs we're going to use. Let's get rolling! We might as well do all the power and ground connections in one go. Let's not forget the USB to serial connector. Whew. Now I'll take it more slowly, wiring each section while always cross-checking with my KiCad schematic. Now I'll do the clock and then the 24 control signals. Welcome to Spaghetti Junction! It's time to face reality, my friends. I'm not exactly a computer scientist. If you have followed my YouTube channel, you might already be familiar with my DIY Flash programmer here. Let's use it to write the control microcode and the operating system data. Okay, I think that's it. But will it start up? Let's find out in the next video. No, just kidding. I'm as curious as you probably are if you've made it thus far. I'll hook up TeraTerm to the USB to serial board and off we go hitting that reset button. And whoa, this makes me smile. The OS fired right up. So, that's probably the easiest way of getting your hands on a Minimal in case you are not a fan of ordering PCBs or doing a lot of soldering. You can also play around and test things more easily on a breadboard. We gotta play a game of Tetris now. And this is it for today. Which version of the Minimal do you like best? PCB or Breadboard Redux? Please write it down in the comments. Leave me a like and subscribe to my channel if you think I've earned it. Take care. Bye.